Welcome back. It's time for video 3 of Unit 4, and we'll be focusing on information that you can find in your textbook from section 12.3. This time we're going to talk about markdowns, and we'll talk about what happens when things spoil and are not able to be sold, and what impact that has as we calculate markups, markdowns, and selling prices and costs. So with no further ado, let me share this PowerPoint with you, and here we go. All right, content from 12.3. Basically, think of it this way: we're going to mark something down if it's got some kind of a damage, or in any way we look at it and say we're not going to be able to sell it for what we hoped. It might be a day-old item. You've seen this when you go into grocery stores. It pains me to walk by the bakery and see all of the donuts that are marked down because they were yesterday's donuts. Again, change of seasons. You walk into Target at the end of the holiday season, you see all the old DVDs that reference the Christmas spirit. It's like, okay, well, I'll mark that down and blow it out. In some contexts, I think stores maybe have diminished a little bit what they mark down in terms of end of seasons and maybe just stash it and bring it back again the next year, but we'll see. All right, so what we're going to work on here is basically trying to figure out how much should we sell something for if we're talking about a specific markdown. All right, and then what's the percentage as it relates to what it used to sell for? Okay, so when we look at a problem, like we'll roll right into one here. Okay, Frosty, everybody's favorite's Frosty. All right, fa la 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 la, the season's over, and Frosty DVDs were originally at 25 bucks, and Target has decided to blow them out of there, and they're going to decrease the price to $15. We're supposed to all find a dollar markdown. Again, I don't know that we need a formula to do it. I think it's probably just the difference of those two numbers. But to calculate the markdown percentage, it's going to be important for us to realize that we're going to base these percentages on what the original number was before the change. Okay, so here's our markdown. It's exactly what I advertised. It's going to be that $12 decrease from $25 to $15. And now for us to talk about percentage, what percentage was it marked down? Well, you're going to have to base that $10 figure compared to what the original cost of the DVD was. And there's your $25 going into your denominator category. And again, grab your calculator if you wish. If you're really good and adept at converting what you see as fractions to clean decimal values, that's cool too. So it's a 40% markdown, and that $25 Frosty DVD is now reduced to 15%, or to $15, I should say. And that does represent a 40% markdown on the $25 original selling price. All right, so it's not hard to do. Find the difference in dollars and make sure that if you're finding percentage markdown, you're comparing to what the cost was. Your denominator would be the original selling price before the reduction. Okay, now what we're going to look at on this upcoming example is a problem where we're going to do a whole bunch of markups and markdowns in context of a problem. But the thing you got to be careful is we're always going to be operating from a specific point, and that number point will be changing as we make up markups or markdowns along the way. So it's important that you say, well, what's my base number as I build this thing? So I'll give you a minute to read here. Tim's is going to pull a TV in, and he's going to pay his supplier 50 bucks, or I'm sorry, 500 bucks for the TV. On March 3rd, Tim's going to mark the TV up 80% on selling price. Okay, now the problem, as we've seen previously, we do not have knowledge of his selling price. We have knowledge of his cost. So the first thing we'll do is we'll find out what that original markup turns out to be. There's your formula. Selling price is found by taking cost and adding to it markup. As we've seen previously, the unknown is S for selling price, and that makes your markup, which is an 80% markup on selling price, an also variable term. All right, so let's subtract 0.80S from both sides. Let's cluster the unknowns to the left side of that equation and grab a calculator because we're going to divide both sides by 0.20. All right, and if you do that successfully, you're going to find out that Tim's is going to sell that TV on March 3rd when you were to walk into his store for 2,500 bucks. That would represent an 80% markup based on selling price. So that's no different than we've done previously in this unit. Same action, same run. Now, for whatever reason, the TV doesn't move. All right, so Tim decides on March 18th he's going to mark it down 30% based on selling price. Well, we now know his selling price. His first base number is that 2,500. So let's take a look at what happens as we move to March 18th, advertising a markdown of 30%. All right, so he's going to mark it down 30%. So if you and I were to walk into that store, we would still pay 70%. We've done this complement trick before. I think it works pretty slick here. So I'm going to advertise that as your method of solution. So we're going to find that new sale price on March 18th by simply taking 70% of the $2,500. So if we walk in there on March 18th, that TV at Tim's will now be selling for $1,750. And that represents a 30% markdown on the price that was initially $2,500. For whatever reason, the TV still doesn't go. So he's going to mark it down again on March 30th. So let's focus what happens, knowing that what happens at March 30th is going to be based on that 1750 as a base number for selling price. All right, so you ready? It's marked down 20%. You guessed it, man. We're still paying the other 80%. So we're going to calculate our selling price by taking just 80% of 1750, which was the selling price after the first reduction. Okay, that was the selling price after he knocked it down on March 18th. Okay, so 80% of 1750 means that his new selling price for the TV is $1,400. So, all right, we've constituted our second markdown. Nobody buys the TV. So Tim does the unexpected on April 1st. He marks it up 10% on April 1st. Okay, again, make sure you realize that that's a base number now of 1,400 as we play. This time we will not take away a markdown percentage. We'll add on. So we won't see a number like 80% as we saw here, 100 minus 20. We'll see 100 plus the 10. All right, but it's the same context. So let's talk about April 1st. April 1st, 10% markup on that 1,400. So our percentage now is 100 plus the 10, or 110 as a decimal number. That's 1.10. So using the same idea that we've looked at previously on this problem, we'll do a straight multiply and find out what that new selling price is. We're not shocked that it's higher than 1,400 because we were realizing he's going to do a markup. So on April 1st, he marks the TV up to $15.40. And the question we were asked is, what is the selling price on that TV specifically as a result of that markup on April 1st? So our answer would be $1,540. Going to transition a bit here. We're going to talk about what happens in terms of things that are not able to be sold. Baked goods, flowers might wilt, fruit might get a little spotty, might be a little past ripe. So in those contexts, we might have to modify our selling price based on the fact that we may not have the full amount of items to sell that we previously were expecting. We certainly aren't going to sell those things at full price anyway. Okay, so your author advertises a 5-step process, and it's not that difficult. Lots of letters. I don't know about you, sometimes letters just kind of swimming around. It looks like alphabet soup. So we're going to calculate the cost of the item. That's just how many is he buying and what's the price to get each one. We'll figure out the markup, and we realize that can be based on selling price or can be based on cost. We'll calculate the total selling price by taking the guy's total cost and adding his markup figures. And then we'll figure out what we have to do to account for the fact that some of this stuff is not going to be able to be sold as we try to find out how much we'll sell the remaining things, the things that are good. All right, how much should we price those individually so that we recoup the desired amount? Okay, it's not that difficult. Let's go look at a problem. We got Betty here. She's got a bakery, and she made 30 dozen donuts. All right, now she expects that some of those aren't going to be able to be sold because they get stale. Not everybody drives in today, and maybe not all those donuts are going to be marketable. Betty, the donuts cost her $2 per dozen to make. She wants to make 120% markup on cost. All right, so the question says, how much should she charge for the donuts that she will have available to sell so that she makes that cost figure and that profit that she wishes? Okay, so let's go get it. The cost for Betty for these donuts. Remember, back there it says it costs her $2 to make each dozen. She's making 30 dozen, so her total cost is $60 to get those 30 dozen donuts in her shop ready to rock and roll. Betty's not going to sell them at cost. Oh, no, nobody would. You want a markup. Betty wants to make some bucks. So she wants to mark up 120% based on cost. So if we find up her markup, it's simply going to be 1.20. Kind of again, that's the 100%. All right, the 120%, 1.20. So her markup is going to be $72. All right, so she's marking up the donuts that she cost. It cost her $60 to get. She's going to add a $72 markup in her selling price for those donuts for the entire block of donuts would be found by simply adding those numbers. And her selling price for the donuts is $132 for those 30 dozen donuts. So if we wanted to say, hey, she's going to sell them all, man, it's a banging day here at the donut shop, nothing's going to go to waste, we could calculate the price per donut dozen by simply taking 132 and dividing by the 30. But unfortunately for Betty, she's going to have some things that are not able to be sold. So let's talk about the donuts that aren't going to be good. All right, so that's 10% of the original 30 dozen. So that works out to 3 dozen donuts. So she's not going to sell all 30. She's going to wind up feeding some to the birds, all right, at the end of the day that didn't get sold because they got stale. So if we want to find out how much she should price her donuts that are going to be sold so that she recoups that amount that she saw on that previous slide, let's approach it. All right. So she should say, all right, well, you know what? I'm going to be selling 27 dozen donuts. The 30 take away the 3 that we fed to the birds. All right, so what we're going to do? Well, hey, on that previous slide, we figured out that she needed to sell for $132. So we calculated that on the previous slide. We're going to divide it by the number of dozens that are able to be sold. In this context, that's the 27. So if we do that with a calculator, we're going to find that for her to make the profit she wants, which was that 120% markup on these donuts, knowing full well that she wasn't going to sell them all, okay? So she's going to sell the dozens at $4.89 for each of those 27 donuts, and that would allow her to gain the requested or wished for markup and on selling price relative to cost. And that, my friends, ends video 3 for Unit 4. We'll be back in a bit with video 4, and that'll wrap down Unit 4. So hang in there, and we'll see you soon. Bye.